Hello, everyone. My name is Alex Murashkin, and together with my coworkers Sunshine and Haitham, we looked at cross-chain messaging protocols. So we have a lot of active chains now, right? So that's more than 100 L1s and more than 40 L2s by now, and even more and more coming. And yeah, cross-chain interoperability is challenging, right? So it's not just bridging assets from one chain to another, but it's also about synchronizing arbitrary state or making arbitrary smart contract calls across chains. And of course, there are multiple proposed solutions to this problem, right? And but which ones are out there? And what are the similarities or differences or trade-offs? Like we know there is the blockchain trilemma, right? So obviously some of that can be applied here. And in the end, as a Web3 developer, what would I use for my application, right? So that's something that, that is keeping us up at night. And previously, we spoke a lot about EVM to EVM bridges. And we gave a few talks here last year regarding the bridge designs and also bridge hacks. And we wrote some papers, gave talks in some other venues as well. And this time we are taking it up, taking it one step further and talking about cross-chain messaging protocols as a more general problem. And we'll look at certain dimensions and aspects that could be useful in this regard, and we'll give an overview of a few example protocols, including Acceler, LayerZero, Hashi, Backgnosis, and Chainlink CCIP. And we'll try to do some comparison and takeaways, but it's very hard to do like a deep dive comparison here because things keep rapidly changing. So we just did kind of our best to do some very, very initial high-level comparison, just maybe to give some idea. And of course, future work could involve a more and more detailed and systematic comparison of various protocols. And what should we look at, right? So, well, first, of course, the number of supported chains, right? Because number of chains keeps growing, and we might be looking for protocols that support, at least 50 chains, right? And yeah, so what is the design class, right? Some of them might be coming with a separate side chain that is kind of everything is centered around that. Some of them might be coming in a different shape, like for example, it could be a network of 3 layers or some other protocols, some other off-chain components. We can look at centralization and upgradability. It's not uncommon for protocols to have some way of privileged access at the beginning, in the development phase. Yeah, of course, we can look at certain criteria like message size and latency. Maybe some of them are more optimized in that regard. Costs is an important aspect there for end users and for operating. Yeah, all these protocols might be different in terms of how they implement their consensus, right? So number of participants, the number of votes needed for the supporting vote, or number of malicious votes required to harm the network, which kind of defines the threshold for security. And more generally, what are the security and trust assumptions here, and what are the risks? So all these things could be useful to look at. We only managed to look at some of them. Let's start with Acceler. So Acceler is a programmable Web3 interoperability platform. And here I'm sharing some links to their website, the GitHub repositories, and the white paper as well. It seems like this protocol is live and can be looked at using this live dashboard. Yeah, the number of supported chains, it looks like it's 50 and more. And the protocol defines its own mechanism for supporting cross-chain tokens. They call them interchain tokens. And we will see that other protocols have a different way of describing their mechanism. And in terms of distinctions for design, this one has its own network with a dedicated threshold consensus implemented. So there is a bunch of validator nodes that running and pretty much have a way of deciding which message goes through. In terms of transaction flow, of course, all users have to start with compensating the network for gas, right? That's kind of inevitable unless there is some kind of subsidy from the chain owners themselves. And once this is taken into account, user calls the so-called gateway contract, where they specify the destination chain and the target address and the payload to send to that method of the smart contract on the destination chain. Right, so that's kind of a more general approach to cross-chain communication. So not just bridging the assets, but sending arbitrary data across chains. And usually there is an emitted event, just like with any bridge implementation. And there are relayers that are listening to those events and submitted to the Acceler network for processing. In this case, anyone can run a relayer, and the network also provides a free relayers in this case. Next, the validators of Acceler network agree on validity and the content of the message to be relayed. They form the batch of commands, and they pretty much facilitate execution of those through relayers on the destination gateway. And the important part here is this step number 8, the validation of basically the payload and the method to make sure that it's approved by Acceler validators, right? So this is the ultimate condition that things are indeed approved and validated and can be executed on the destination chain. In terms of fees and costs, like we will see with any protocol, the fee structure will be composite. So there will be multiple, essentially, steps in this chain that you've just seen, the processing chain, and each of these steps need to be paid for. And of course, in most cases, it will be end user who will need to compensate for these costs. Yeah, the interesting part is that the gas is not always predictable, right? Because you have two chains, and users usually have the tokens or assets on the original chain, so they can pay the fees using that original, the source chain's tokens or ETH. And the actual execution on destination chain is what can be variable depending on gas price, right? Depending on latency and so on. So, but thankfully there is a refund mechanism. So in case you overpaid, it looks like in this protocol there is a mechanism to get your money back in case you haven't used the entire amount. And in terms of the security and liveness assumptions, of course, the relayers and validators need to be live and secure. They need to continue to be operating in order for this to work. And of course, there are certain security properties that are usually validated during audits. And most recently, of course, we see the need for infrastructure audits. So not only verifying that the code is good, but also that this is deployed and running successfully in a secure manner. Let's move on to LayerZero now. So LayerZero is an omni-chain interoperability protocol, and you can find the site and the GitHub and documentation links there. So they recently released a new version, V2, and we try to do a slight comparison here between the two versions as well. It seems like they are live, and they have close to 100 supported chains, which includes also non-AVM chains and mainnets and testnets of various chains. So yeah, it seems like there is a lot of coverage there. They define their mechanisms for cross-chain tokens and call them omni-chain fungible token, which is OFT, and they also have ONFT, which is the version for non-fungible tokens. In terms of design, they have the network of relayers and an oracle in version 1. And in version 2, these two components have been made more generic and replaced with decentralized verifier networks and executors. In the V1, and this part is also preserved in V2, LayerZero endpoint is what they call the smart contracts on each chain. So there has to be deployment on each chain, on each supported chain for this to work. Then there is a network of relayers. So they are run by LayerZero, but can be run by anyone. And for oracles, from what I saw in the documentation, V1 was using Google Cloud Oracle. Previously, it was using Chainlink. And in the V2, later we will see that this was changed. And the general flow of the message is LayerZero endpoint is pretty much an entry point like the gateway contract for the Acceler network, where user application sends some payload, and this gets stored on chain in the source chain. Then the Oracle component waits until the given block is committed to chain A and notifies chain B's endpoint. Chain B is the destination chain in this case. And upon confirmation, relayer sends packets and proofs matching the current block, and chain B's validator component ends up validating the packet and ends up forwarding that to the chain B's so-called communicator component, which forwards it to the end user application. And the important part here is that Oracle and relayer, even though they work together, they have to be independent, so that there is two different sources of pretty much validation for certain events happening. Of course, relayers are also important for liveness reasons. Protocol in V1 had the privilege rows, which involved upgrading the library versions, which makes a lot of sense. So having to develop a protocol, it's hard to make it decentralized at the very beginning. All you have to make sure that there are audits taking place and that all these trust assumptions and privileged roles are well understood. In terms of fees and costs, just like in case of Acceler Network, there are multiple costs, right? You have to pay relayers, oracles, native protocol fee, and they're usually hard to predict. And just like last time, in the last case, users usually do not have token on destination chain, so they have to be charged in the token on the original chain. In version 2, Oracle was replaced with the so-called decentralized verifier nodes, and applications looks like they can configure which decentralized verifier nodes to use and which parameters, which is quite interesting. And there are around 28 TVNs available at the moment, and notably some of them, as you see on the bottom right screen, come from Acceler and CCIP. So we actually see the convergence of these various protocols where they can use each other's pretty much nodes for Oracle purposes through certain adapters. And we will see a similar thing later with a different protocol. And yeah, so let's move on to Hashi by Gnosis. So my understanding was that this protocol is still in development, but there is a version that is working. And in terms of design distinction, it's centered around the Gnosis chain, and there are adapters for multiple communication protocols, right? Because the intention for this protocol is being the EVM hash Oracle aggregator. In terms of architecture, you have these various communication protocols that are integrated through adapters, and on the right-hand side you see the list. And notably, what we saw, Chainlink CCIP and LayerZero are on that list as well. So yeah, so we kind of have this interesting convergence in this regard. And Hashi is an interface to query all the stored block headers in the adapters, and therefore they facilitate pretty much determining the trust and security properties of cross-chain communication. And the whole value proposition there is that instead of relying on one source of truth, you are relying on multiple sources of truths from all these various protocols, which ultimately support enhances security. So that's kind of the premise. We do not have much time, but for Chainlink CCIP, there is like a mainnet early access that is available, and their design distinction is that they rely on so-called decentralized Oracle networks, and they have two types of Oracle networks: the so-called committing DON and the executing DON. And there is a third component called the risk management network. And on the next slide, we will see how this is all working together. So the committing DON listens to events and waits for finality on the source chain. And then it stores that commitment, and independently, risk management network approves or disproves a given event. So there is pretty much like a similar system. There is some resemblance of the previous designs that we've just seen. And executing DON waits for both of these components to give the blessing and completes the interaction on the destination chain. This is kind of the high-level design here. So now let's move on to comparison and initial takeaways. So in terms of similarities, I think that if you're kind of looking at the watching the presentation, you will realize that there are certain architectural similarities there. So all of them require off-chain components. It's very hard to do it completely on chains. It seems like there are so many moving pieces, so many chains to be supported, and all of them require some way of handling finality on original chains, right? So this is not a given, but has to be implemented and has to be done properly. On the UX side, we have two issues, but they are kind of inherent, so I do not see how one would solve them without sacrificing other properties. So these two things are latency and fees. And on the deployment side, rolling out to multiple chains can be challenging because essentially you have to run you have to deploy the same set of contracts on multiple chains, and you have to make sure that the relayers and whichever components are there, they are all connected across chains, which is also a hard problem in terms of operations to solve. And in terms of security and liveness, there are some similarities as well, but all of them share the fact that trust is still required. So maybe in the earlier phases, trust to protocol admins, and in some cases, trust to certain components. For example, to pretty much the various committees or the oracles, or pretty much there is some trust assumption that is probably necessary for you to be confident that certain event not necessarily deposit, but certain invocation of method took place on the source chain. In terms of differences, we see that there is some distinctions in terms of architectures, right? So Acceler and Hashi, they seem to be centered around their own sidechain, whereas LayerZero and Chainlink's solution require off-chain relayers and executors, and as well as oracles or DVNs. Basically, they're just like different names for similar purpose components, and we've seen that pretty much CCIP also had this different role for enhancing, for validating the security aspects of it. And in terms of state of readiness, I think there is some distinction there, right? So it seems like there is certain components are live, but certain components are still in development phase. And even those that are live, they keep being developed, so it's not easy to keep up as well. And what do we choose, right? So some initial thoughts. As a Web3 developer, I want a protocol that is live on mainnet with many supported chains, which is well documented and supported. We need cross-chain token support at the infrastructure level, so we don't have to reinvent the support there. And yes, I usually value simplicity in designs to the reasonable extent, and it's good if there is some flexibility in trust assumptions. But in the end, what I realized is that everyone will make their own decisions. And in this regard, we see it as choosing cloud provider in the end, right? So I think it will end up at this point. Thanks, everyone.